You guys can see I just hit the record button, which is all good. That means you will be able to download it or pass it along to other folks. Okay, you got a question before we get started? Oh, thank you, Eric. Appreciate that. All right, so let's get started. My name is Michael Kennedy. I know I've spoken to some of you out there in the crowd, so I appreciate you coming. I'm an instructor for Developmentor, and I've been doing a lot of stuff with this NoSQL movement and MongoDB lately. So a lot of fun. I think you're going to find this to be a really interesting technology. You can follow me on Twitter at @mkennedy. If you want to talk about this talk, use the hashtag #Developmentor. Okay, so let's get started. The first thing that I want to do is ask you all a quick poll about your experience with NoSQL, with MongoDB, and so on, just so we kind of know where everyone's coming from, and also maybe a quick poll to just see where you physically are. So let me show this one first real quick. Give me a quick answer about where you guys are coming from. Other. Interesting. Now I'm wondering where I forgot. I guess maybe Canada. All right, good to know. The reason I'm asking is we schedule a lot of these webcasts, and we're always trying to figure out what's the best time for people to show up. So that'll kind of help us do that, set these up for your time a little bit better in the future. All right, so that's one poll. And I have another quick one. This is the one I really wanted to start out with, the one I was referring to, is are you using MongoDB or some other NoSQL database? So we have a couple of folks who are using it. That's great. Some people using other. There's a ton of NoSQL databases out there, and that's one of the really exciting things about this whole movement is there's just a lot of innovation going on and a lot of almost like the wild, wild west out there. So very nice. Great. Let's go back to my desktop then. Excellent. All right, now I have a set of slides for you that we're going to go through that kind of hit the high points of what is NoSQL, what is MongoDB, what's all this stuff about, how do you work with it, as well as I'm going to give you a bunch of resources that you can check out after the webcast, a big page full of links and demos. I'm going to give you those as well. But I want to spend most of my time working on demos and actually giving you some hands-on experience using this stuff, because you hear a lot of talk about NoSQL. You hear about how it can be more agile potentially, maybe it performs better, but at the same time it's really vague. It's hard to get your head around what this NoSQL stuff actually looks like. So we're going to spend a lot of time writing applications on that. But first, let's think a little more broadly about what is NoSQL. So if we take a step back from, say, MongoDB or some particular choice of a database and just think about what is this whole NoSQL movement about, my interpretation of it, or thinking about it, this is what I think the NoSQL movement means. It says the NoSQL movement is about reevaluating the constraints and scalability of data storage systems in the light of the way that modern web applications generate and consume data. Okay, so look at some of these websites that I've chosen down here. If you look at how Twitter generates and uses data, or Bitly generates and uses data, or any of these others down here, they're very different than the way many web applications work, and certainly different than the way web applications worked 5 years ago. If you think about some massive place like Amazon.com, Amazon.com has an enormous amount of data, but there's not a huge amount of user-generated data compared to the overall data they have. Right? Most of that is relatively static. But on the other hand, if you think about Twitter, Twitter is a place where there's almost as much data generation as there is data consumption. Many people will insert data into the Twitter system, send out a tweet in one way or another without ever even attempting to look at what is on Twitter. Similarly, with Bitly, if you look at what you can do with Bitly, at first you might think it's just a URL shortener, but if you look at a lot of things from Bitly, one of their secret sauce pieces is here. Let's see, just pull up something. The secret sauce that Bitly brings is really, I guess this is not a great example because nobody went there. Let me find one that has some people that checked it out. This is kind of funny. Is they have real-time analytics around what activity is there with this URL. So every time you click one of these links, this will generate one of these little entries in the bar graph, and this updates every 5 seconds, as well as you have all this information coming in from Twitter, and if you scroll down more to the bottom, and a lot of them, there's stuff from friend feed and all over the place. Reddit comments coming here. So even though it looks like a simple system, there's tons of user-generated data being triggered when you're working with Bitly. Foursquare, similar like Twitter, you say, hey, I'm over here, I'm doing this, I became the mayor of that coffee shop, or something silly like that, right? And SourceForge is on here because SourceForge, at least a few weeks ago, I'm not sure if this has changed with the adoption of Foursquare, but SourceForge is, as far as I know, the largest installation of MongoDB, and we got some really interesting stories around the performance that they got by moving to the NoSQL MongoDB style of programming. Okay, so if you look out across the broad software development landscape and you think about how people use data in databases, you'll find that they largely just assume that what you need to be doing is working with a database, right? A relational database. So I wanted to try to express that in kind of as strong terms as I could. So the phrase I came up with was, if you look at how people work with data these days and what they choose for their data storage systems when they create new applications, I would say that starting from a relational database is virtually an axiom of software development. And remember what that word axiom means, right? I chose that word carefully. It's a proposition whose truth is so evident that no reasoning or demonstration can make it plainer. And by that, what I mean really is, when was the last time that you actually weighed the trade-offs between using a relational database, right? If you're starting on a new application, you probably think, I have data, that data goes in the database. You maybe would think, if you're kind of cutting edge and doing things differently, you might think, well, maybe I should put that in a cloud database or something like that. But most likely, I would say you're probably just thinking regular database. So let me ask you all that question, or let you answer it rather. So have you seriously considered alternatives? Yeah. Excellent. So that's pretty good, actually. When I asked this question at the Portland Code Camp, which had a ton of attendees, especially in the NoSQL versus database or relational database panel, only one out of about 25 people said that they were seriously considering that, not in the future, but in the recent days. Okay, excellent, good to know. I suspect that the audience is a little bit skewed if you guys are willing to come out for this talk, right? Okay, now one other thing I'd like to add about this NoSQL movement before we get into the details is that I don't believe that NoSQL means anti-SQL. I think if you look at this statement above, that starting from a database is an axiom of software development, it's simply a truth that we have accepted as an immutable fact we cannot change, right? If you look at it that way, I believe the reason that people are so excited about this NoSQL stuff is that they now have a choice where they felt they had no choice at all. Okay, you used to just think, well, okay, my choice is between Oracle and SQL Server, or SQL Server and MySQL, but that's not really a choice. That's just details, right? But this is actually a choice, a significant way of doing things differently that have trade-offs, and I think that makes it very interesting and powerful. Okay, another one of the issues that we run into when we look at relational databases is, at least as .NET developers, what we do is we write applications that work with objects, C# objects, VB objects, .NET objects, something like that. However, when we need to save those objects in a database, we can't save them in the size and shape that they are, so they get shredded apart and put in different tables, and there's normalization tables that wire them back together. And this whole different way of storing your data from the way that you actually use and create your data is referred to as the object-relational impedance mismatch. Right? They aren't quite the same. The way identity works isn't the same. The way pieces refer to each other isn't the same. Objects have arrays or collections, whereas databases have foreign key relationships, things of that sort. Now, what I think is fantastic about some of these NoSQL databases, and MongoDB in particular, which is one of the reasons I started playing with it, is you can store your objects in the same shape that they are in memory. So if I have, say, a customer that has an array of orders, well, I just stick that thing in the database, and that's the shape it is inside of the database, as we'll see. So you can just say no thank you to that object relational impedance mismatch. You don't have to worry about it because your objects are not changing shape. Now, you may feel like, well, once you stick something into the database that way, it probably will lose the ability to do deep queries. Like if I wanted to find out all, suppose I had my customers and they had their orders. I wanted to find out all the people who had ordered cake that day or something. With MongoDB and some of these other databases, they still have rich querying capabilities. So I could still, even though there's this nested relationship in the storage mechanism, I could still write an indexed query that says, find me all of the customers who have ordered cake on this date. Okay, so very nice. You don't have to give up a lot of the database features, but you don't also have to bear with this relational impedance mismatch. Now, why is there all this excitement around this NoSQL movement? I think there's really two forces that are driving the excitement as well as the creation of all these different database options. And I think they're kind of independent of each other. One of them is about the ease of use of your database, right? Ease of deployment, the ease of development, the agility to be able to change your app without having to go through a bunch of rigid mechanisms or a bunch of rigid processes around changing your database schema, moving into production, and so on. Because we'll see most of these NoSQL databases are not entirely schema-free, but they have flexible schemas. So if your shape of your objects changes, well, the database can still just take it. Okay, and that's one, and I think that is maybe the most compelling reason, although the other reason is, of course, their performance. So a lot of these NoSQL databases give up certain features of the relational databases in order to gain performance or ease of use. And probably the most common piece that goes away is relationships. So there's no joins, there's no primary foreign key relationships, none of those things, even though there still are indexes and queries and things like that. Because when you start thinking about scaling out beyond just one system, imagine I want to get 10 commodity hardware boxes, right? Think Intel machines, 4 gigs of RAM, that sort of thing, $1,000 machines. And I want to put 10 instances of, say, MongoDB on them and just insert into them and have it automatically partition my data out across it. We'll see that that's one of the features that MongoDB has. You can set it up to do what's called auto sharding. You insert into this kind of master thing, and it just automatically chooses the right one of those 10 systems to put it into. When you do a query, it will run the query in parallel across all 10 systems. And that's fantastic for performance, but it really falls apart if data on one machine has to be joined with data on another machine. It just doesn't work anymore. So in order to make the scale-out system work, as well as to keep things simpler, the NoSQL databases typically do not allow joins or relationships. Okay. The other area where they give up something, although they give you something in return, is they give up durability a lot of the times. So there's no guaranteed durability mechanism in MongoDB quite the same way that you have with SQL Server. But with certain types of replications and API features, you can get a lot of that back, or maybe even more if you set it up right. Okay. So if you guys have any questions, feel free to stop me, but we're about to get into some more interactive things. All right. Now, you've heard me talk about it a bunch. It's in the title. MongoDB is the database that I've been working with, and I think that it's one of the best NoSQL databases because it doesn't go too far away from the relational model, the queryable model, but at the same time, it still is far enough away to give you a really interesting and new choice. Right. So this is from their website, this little phrase here, and it says their slogan is combining the best features of document databases, key value stores, and relational databases. Okay, so by best features, they mean the ones that work well, and of course they drop out the ones that don't. We talked a little bit about relational databases and the problem with scale out, with joins and things. Also, the durability guarantees can really mean that your disk I/O is the limiting factor for your performance, among other problems. Key value stores are pretty much as fast as it gets. That's like an application which is more or less a dictionary that writes the files. The problem with that, though, is you don't have rich queryability. The only types of queries you can run on key value stores is based on the key or the primary ID, which, of course, means you can't ask questions like, who are all the customers who ordered cake today? Right? And document databases allow you to store, they call them documents. You can almost think of them as object graphs, but they're not quite object graphs. They don't have pointers back to each other. They're kind of just, serialized acyclic graphs of data, but they're a certain subclass of object array type things. Okay, and if you want to get this, of course, we can just go there to mongodb.org is where it is. And you can go download it. Okay, here's a bunch of apps that are in production. And if you want to download it, you can see you have pretty much all the reasonable choices anybody would make. You can use this on OS X, on Linux, and Windows, and Solaris, all of those 32 and 64-bit systems. Okay, I'm running 64-bit Windows 7, so I got this one. And this 1.4.3 just came out 2 days ago, maybe yesterday. I can't quite remember. Could have been right the night. But it came out very, very recently. They're changing these quite quick. I'd say every couple of weeks a new one is coming out. So you can keep downloading these. All right. And it's, of course, open source, free. Another really important feature of MongoDB compared to some of the others is even though it's open source and free, it also has commercial support. So this is created by a company called Tengen, and they offer commercial training and support specifically on this, I believe. So that's, if you're going to try to use this in a commercial space, that's pretty helpful. All right, let's look at a few features of this, and then we'll get on to our demos and start writing some apps. So MongoDB is one of the more full-featured NoSQL databases, and one of the areas that's really important is you have these rich queries. Okay? And I say like SQL because you have a query language. It happens to not be T-SQL or ANSI-SQL or anything like that. It's something else we'll talk about in a sec. So you have the concept of creating indices. If you're doing queries on, let's go back to our customer example. You'd have a customer, and they would have a customer ID, which is this thing called an object ID. It's kind of like a GUID. That's auto-created by MongoDB. But you also might want to do queries based on username or maybe based on the state that they live in. So you can go and set up an index on their, say, state property, in which case you could do super fast queries. You also have keys. Right? Primary keys are pretty much all you get. There's not really a foreign key relationship, even though you can mimic it. Now, with these NoSQL databases, you have a lot less structure. So instead of having what we call tables, they just call them collections because they can be nested, right? Like I have my customers, which contain orders. And the schema is implicit. So instead of having tables and columns in a fixed schema, you can store these rich objects like a .NET Object Graph. You can push that in and just store that as a document. Well, we keep saying document. What does that mean? I mean, in the lower left here, the actual storage mechanism may be familiar to you. It's familiar to many web developers, at least. The storage mechanism is JSON. Technically, it's something called BSON for binary JSON, but for all practical purposes, you can think of it as JSON. And then instead of using SQL for the query language, you use JavaScript, and there's special operators and stuff in there. Right? Of course, we're not going to query it in JSON. We're going to query it in LINQ. Now, another one of the features about MongoDB is around performance. So MongoDB has pretty insane performance especially on low-end hardware. So I've ended up doing a fair amount of testing with Eric, one of the guys who's on the Webcast here. And on really high-end systems, it seems like SQL comes closer to MongoDB, but on the lower-end systems, MongoDB is off quite a bit better. So, you can imagine that you can leverage commodity hardware more easily with this, which is a very nice feature. And one of the main ways that you get performance increase is you don't have durable writes and fully committed transactions. However, to sort of backfill that with some guarantee that stuff is written, MongoDB lets you do all sorts of replication. So you can set up master-slave details. You can say, when I do an insert, don't return and tell me the insert was done until it's replicated across multiple backups and all sorts of things. So you still get durability, but it's just not in quite the same way. And then there's this feature of auto-sharding, an algorithm called MapReduce, which is pretty much how Google works, how they can run queries across huge amounts of data. Basically, you split your query up into a bunch of pieces that run in parallel and then pull it back. And then also it has really nice replication. We'll talk more about that later. Okay, so who's using, I see there's a question before I go into this. Let's see. Is the auto-sharding feature considered commercial now? No, I don't believe it's considered commercial yet. I'm pretty sure that that's still in beta. It could have changed, but the last I heard it was still in beta. Good question, good point. Is there a certain category of data that lends itself to NoSQL? Is there a certain lifetime of the data that lends itself to NoSQL, such as is for a time NoSQL and then at some other point is in a relational database? Good question, Brock. Yes, there is a certain category of data that is better. I would say data that you have less reporting concerns on fits better in MongoDB, as well as non-financial stuff. Right? I talked a little bit about the durability. If you absolutely must not ever lose a single piece of data, and you're not willing to do this sort of recover from a slave if there's a failure, then you might not want to put your data into there if it's really critical, like credit card stuff. Although I think if you set up the replication correctly, it would probably be fine, but you probably, at least getting started, you might want to stay away from that. One of the areas where the MongoDB stuff excels more than SQL Server is around inserts. The insert speed is really pretty high. So if you have lots of inserts, that's one. Yeah, so hopefully that answers your question. All right, now, where is MongoDB used in the real world? All these guys down here are using it. Bitly is using it. Foursquare is using it. And if you want to see some more, there's a whole list of them down here. Right? That was sort of that rotator. You can go and see them all. There's like 30 companies. And some of them are big, like the New York Times and Bitly and Foursquare and SourceForge. SourceForge, of course, is a really interesting story around performance, which we'll come back to. Okay, so that's probably more than enough time with talking about just the theory of the stuff. Let's actually get down to it and write some code. So first thing I want to do is I want to install MongoDB and hook up to it. Now, if this was SQL Server, I would tell you guys to go get a coffee, come back in half an hour, and we'll have it installed, maybe if we're lucky, but it's not. So let's imagine, go over here and say, imagine that I downloaded this thing, and here it is. This would be the zip file, the 64-bit version that you got. Let me make sure it's stopped over here. Oh yeah, okay, stopped. Good. Okay, so here's how you install MongoDB. You guys have to watch careful because it goes quick. Ready, set, installed. Okay, so you just unzip the zip file, and now it's installed. And in the bin folder, you've got a bunch of exes, but you really only care about the first two when you're getting started. The top one is actually the command console that you control and configure. MongoDB with, and MongoD is the database. So if you run it, you have MongoDB up and running. And that might shock you guys a little bit when you see a console window up and running. You might be like, oh my gosh, what is this, right? Where's my Windows service and all that? But of course, you saw me check over here. You can install MongoDB as a Windows service. And one of the links at the end I give you on my blog, you can find where how to do it. It's pretty straightforward. Okay. So this has got it up and running. It's waiting for a connection, but let me just drop out of that and switch back to this. Okay. So up and running, got our Windows service going, and then we can work with it with this Mongo console here. But let me start a different one so the fonts look better. And then you can ask it questions. So when I say there's a command console, I really mean a console, not like a SQL Server Management Studio. Now this is a little bit freaky and it takes some getting used to, but you'll get used to it. It's not a huge deal. So I can say things like show DB, show DBs, and it'll show us which databases are there. Currently there are none. Okay, but we're going to create one in just a minute, and we'll come back with this console and look at what we get. Right. Now, you can see it's kind of got some, it says JS error. This is actually just a JavaScript shell, so kind of whatever you can do in JavaScript, you can do here. All right, so that was setting it up. That's pretty easy, huh? All right, now, how do we go about creating tables and creating schemas and connecting to it and all that? All right. So that's the next thing we want to talk about. And if you want to program MongoDB, you typically have to go and find what's called a driver, what the Mongo guys refer to as a driver, for the language you want to use. And of course, we're using C#, so we need one for .NET. And there's actually 3 choices. We can choose this one called NoRM for as opposed to ORM. And there's another one called, oh, I can't remember what it's called. Let me just pull it up. So here, get the drivers. Go down to C# and .NET. The MongoDB C# driver is the other really popular one, I would say, by a guy named Sam Totis, I believe, if I remember that right. And then there's this simple MongoDB driver, which is kind of like programming with a fancy dictionary style. It's really close to the underlying JSON. But if you like LINQ, then NoRM is the place you want to go. Okay, this is where all the good stuff lives. And it's on GitHub. It's got a really vibrant open source community and so on. If you go over, there's a nice Google group where you can go get help. Right, so a bunch of stuff, you know, a couple of posts a day, things like that. Okay, so I've already downloaded this, compiled it, and stuck it in there. Now what I want to do is create an application that will let us talk to it. I need to create some schemas and classes and so on. So let's go ahead and just make a new project here. Make sure I can put it in the right place. Put it there. Copy that. Now we'll start out kind of boring with a console app. The next one that we'll write, we'll do some MVC stuff. Okay, so this will just be first Mongo, call it that. Sounds like a bank. Okay, so let's imagine that we just want to store some customers and possibly some orders or something to that effect, right? So the way that we would do this is we could even create a data access layer if you think that that makes more sense. You know, for real projects, of course it does. For a demo, maybe less. But let's call this, I'll just call it DAL because I'm kind of lacking creativity today, I guess. So let's make a class called customer. Okay, and use ReSharper to fix up the name of the file. Much better. And let's give them, I'm not sure where that suggestion thing came from, but that's really annoying. Thanks, ReSharper. Go away. Anyway, I guess we'll just have to stay away from it. There we go. Okay, so we need, for all of our top-level objects that we're going to put into the database, they need a primary key, and the primary key always looks like this unless you use some attributes to kind of trick it. And in my experience, I just find it's easier just to roll with it. So this thing called an object ID, and it's called _ID, and this is always created by Mongo when you insert something, even if you didn't say that it was in there. Okay, it's like an auto-incrementing, auto-created ID in the database. Now, I need a reference to that library that I talked about, so let me browse up a little bit here and find it. I already stuck it in place for us. And I may need it over here, so let me just do the same thing. Alright, so let's just download that project from GitHub and compile it. Close up. Okay, and now, of course, we can import this namespace, and it knows what it is. So there's our sort of primary key, and if you try to do an insert with the NoRM driver, it'll freak out and say you can't do an insert because you have no ID. Does it have to be named _ID? No, good question, Ryan. I don't believe it does. I'm pretty sure I could do this. Mongo identifier, just like that. And if I had it capital like ID, let's go with that and see if that works, huh? So you can kind of use attributes to describe it. So it depends on whether you want to go with convention or a little bit more configuration. And then let's say it has a couple of properties, like let's say they have a string, it's got a customer name, and they have a date time, created date. Now I want to bring this up because this is really important with the way that dates work in MongoDB. In the underlying type system or BSON of MongoDB, they're always stored in UTC format, and the NoRM driver will convert them automatically to UTC for you, but it will not convert them back to your local time. So you had better just always work in UTC, or things are going to go crazy. Like you'll do an insert at 7 o'clock and you ask it what time it was inserted, and it'll say midnight or something weird. So be sure you do this. Okay. And let's say we have some orders as well. Let's start out like this. We're not going to quite leave it this way, but order array. Let's call it not orders. Sometimes IntelliSense is just a little too helpful. All right, so let me generate this class. Let Visual Studio generate it and make it public. Great. Okay, so we've got our order collection. Now this defines the schema for our customer class mostly, and then our orders is going to have something as well. So let's say this has two things, a string, a name, and a double price, something like that, say. Okay. So those together, that sort of graph that will be made up of those objects in memory, that's going to represent our objects. This is where we define the schema, more or less. Now, for those of you who have used LINQ to SQL, Entity Framework, anything like that, the way I would normally do this is I would go to my Server Explorer, I would find a database, and I would create something like a LINQ to SQL classes or Entity Framework classes, and pull these over into the designer, and it would auto-generate the customer class and it would auto-generate the order class for me, which I'm kind of happy to just have real objects that I'm making here for my entity classes. That's fine, because I don't have to manage that also in a separate way in SQL or something. But what you don't get, and really the tools probably are not there yet, is what you don't get is you don't get the data context, the thing that has the iQueryable parts where you can run queries against. So we're going to have to make that, but I'll show you a nice little trick on how to do it. Oh, that's a really good question. Does the object ID need to be declared on the orders collection? All right, good question, James. No, because the way that I intend to use these objects, like let's see if I can pull this together real quick. Here. If the object, if the order was going to be a top-level ID, or top-level object where it was the thing that got inserted, then yes, I would need to give it an ID. But it's never going to be, there's never going to be an order alone in the database. There's going to be a customer which has an array of orders in the database. So because I'm never inserting an order as a top level item, it'll always be associated with its customer. From a MongoDB perspective, I don't have to. Maybe to keep yourself sane, you might want to, but you don't have to. Okay. Good question. So I'll go ahead and say that, right? So here's our relationship. That's what we're going to go insert. Now, what I need is I need that data context, and we don't really have that. So I created a code snippet, which I'll give to you. I'll post these with when we post the recording and everything that you can get to it. Called Mongo. I spell it right. Context. If you hit tab, then out comes a MongoDB data context. And let's import these pieces down here. Bunch of pieces. Okay, and then the entity will just be customer. Right? Is that what I called it? Yeah. Yes. Okay, you don't really need this piece here. Alright, so this lets us insert, delete items. It lets us run queries because you can see there's a property called customers. Let ReSharper help me if it wants to. Right, so just like in LINQ to SQL, I would go and do something here. Let me go ahead and just say that the database, well, we'll do this from the outside. Okay. So I'm going to use this class in my program. Let's go ahead and put it into its own file, just so things are more self-contained. Let's go over here and say do some inserts. And hit control period, auto-generate that method, and let's go do a query. Okay. Here we go, like so. Just like you might normally. Well, first of all, let me set the database name. So I'll say Mongo data context. What did I call it? DB context. Put it in the right namespace. Oh, I need to create a reference, sorry. Of course, these are in different libraries now. Reference that project. Ah, that's what it is, great. So I want to set the database name. Let's just call this first sample. So I just made this configurable from the outside, so you could set this from, say, a config file or something and not hard-code it. All right, so let's do some inserts. Let's make a customer. Oops. Customer C equals new customer. And let's set their created date to datetime.utc now. Remember, don't forget that. It'll drive you crazy. And we can set the name to be, I guess I'll pick on myself and make myself a customer. And what I'd like to do is I'd like to be able to go and just add some orders here and just say orders.add, but of course I made that an array. And I said we were going to change it. What I'm going to do is change that into a list. So let's go over here and change this to a list of these things. And we're going to need to initialize this. So new constructor, orders equals new one of those, okay? But if I do this, I can say things like .orders.add, let's say new order, and use some of the object initializer stuff in C# here. So let's say name equals, what did I say, call it cake, and price equals $7.99. Okay. Let's add another order, cake and beer, good combination. 17. And let's go ahead and save this person. And so I can say this. I can say using var context equals new MongoDB data context. And I can just say save. And that's a generic method. So I can save virtually anything that is serializable in here. So I say save C, and it will actually insert that into the database, set the ID, update this in-memory version's ID, as well as store the array and so on. So let's do that one, and let's create a second customer called Bill, and Bill is going to order bread, and that is not that expensive. Okay, and so let's save Bill as well. If I run this, it'll go ahead and do the inserts. Let's go ahead and do this. Fingers crossed, it should all work. All right, now a bunch of stuff happened when I hit that button. There's no output because I didn't pull anything back, but it actually inserted both those into the database. It talked to MongoDB, which didn't have a database called first sample, so it created one. It didn't have what you can think of as a table, a collection called customer, so it made one, and then it inserted those things into it. So let's go look now at, if we ask, what are the databases? All right, so there's first sample. We can say db.firstSample, oops, let's try this, use first sample. And then we can say show collections, and there should probably just be one, but we can say db.customer.find. And then look at that. There's our customer with the object ID set. And these things in here, although I'm just kind of surprised to not see my other person. Did I not insert them properly? Yes, this is a little concerning. Alright, well, I'll figure out what's going on there. Okay, so you can see some people were inserted here. And we can go back and do some queries on it. Let's go and not do our inserts. Let's do some queries instead. Let's say that we want to find, I guess we only have one person right now, so not terribly interesting. But let's say we want to just run a query anyway. So we'll say query equals. Now, here's where MongoDB is really sweet, because I can write real rich queries against this data context thing, which I guess I got to make one of. So we could say customers where c.orders.any, and we could say something like this: O maps into O dot name equals cake. Hopefully I didn't select C. So we could just do that and write it back out, right? So we could write interesting queries based on the sub items in that collection, or just based on the name, or something along those lines. And then we could just say for each CW curly 0 8 curly 1 or 8KK. And customer.name. Okay, so if I run this, it will go do a query against the database. Two questions. So is there a query analyzer? No, there is a way in which to get what would be the JavaScript that's going to execute, but not really a query analyzer. Well, okay, I take it back. There is something that will, you can say, ask it to give you what's called a hint, and it will give you, it'll tell you whether or not it's using an index or not for certain queries, but it's not quite the same as the query analyzer. I don't think it's as rich, but I guess the hint operation is as close as you're going to get. Good question. You assume there's constraints to persist object graphs. So, for example, the same order under two different customer instances. If you wanted to do that, you would have to basically create an orders collection and put stuff into that, and then put an order ID on the collection, on the customer collection, and then basically do the join in memory or on the client side. There's no real concept of join, so you'd have to put implicit foreign key relationship there, bro. All right, let me do a different select. Let's just say where c.name equals Michael. Did I put capital cake? Oh yeah, okay, that's the problem. Now, all this stuff, unlike say SQL, is case sensitive, so be aware of that. It can throw you off. There, Michael ate cake. Now, I'm kind of concerned that this didn't insert correctly on here. It looks like I have this all set up okay. I just last night updated to a new branch off of both the database and the driver. So there might be a issue in there. It's kind of pretty leading edge on some of that stuff. So, but the previous version was working super stable. So don't let that concern you too much. All right. So I want to keep moving. Let's go and look at something a little bit more real than this. All right. So what I want to do is take you really quickly, so we don't run over time too much, really quickly through a more full-featured application that I just made up. I called Surveo.com, and there's really a website called Survey.io, which lets you take surveys. So I was kind of picking on them a little bit. They're pretty cool. So it's just a silly little app that lets you do data-driven websites via MVC. Okay. So let's see which one is which. I better do it this way. I'm going to end up loading the wrong one. Here. Okay, so we have this up and running. I know you may not all be really super familiar with ASP.NET MVC, so let me just give you the real quick rundown so you know what part to pay attention to and what parts are just there and that we can kind of ignore. So for the large part, I've already written this web app because, like you see, we just don't have time to write the whole thing. So the HTML views are written and the logic of working with the underlying data is there, but the part that actually accesses the data has not been written yet. So we're going to work. That's what we're going to do in this quick demo. So you can see we have, of course, a survey thing. So we have a survey class, and it has. Oh, I remember what I did wrong before. Okay, anyway, maybe need to put this on my collection. So we've got our ID. We've got our created date and our description and so on. This is going to describe what our survey is, and it has a set of questions that are going to be embedded into it. And then we, of course, have a question which has choices and it has text, right? So we can have this rich object graph. And then people are going to respond. Users are going to submit responses to our survey. Here we're doing kind of what you asked about, Brock. A bunch of users are going to have a bunch of responses against a single survey, so you don't want to embed that. You want to keep that as kind of a separate table collection. So here we have a survey ID and user ID. This is kind of like a composite foreign key relationship, but there's no enforcement in the data side. You just got to do that in code. Okay, so this is our data access layer, and then we have these things called controllers. And probably the most interesting one is this survey controller here. So we can say things like this. I want to take a survey. So given a survey ID, I can go to this repository, which we're going to look at in a second, and say, give me that survey. Or if somebody's going to post back and submit their answers, they're going to post in this data transfer object as well as the ID. So we'll get the survey, pull it back from the repository, go and make a bunch of changes to it. Right, here's a bunch of answers we're going to set on this response. We're going to get the response from the database, make a bunch of changes, and then say save those changes back. All right, so we can kind of pull them out, make some changes, and just go save my changes. There's not explicit change tracking, like this thing is inserted, updated, deleted, or anything like that. But you could add that, I believe, but I find you don't really need it. All right. So all that stuff is already written. Let's go to the repository real quick and just look at a few of the pieces. All right, this is real similar to what we made before, but let's just go down to 3 or 4 of these methods here I have a user class. I want to create them, insert them into the database, and give them back to the application to work with. So that turns out to be super easy. We just do this. User equals new user. We want to set the username in this case. Equals username. Then I want to save it to the database. User. And then finally, I want to give that back to the app to go work with it. So you might think of this almost like a stored procedure, right? This is kind of where the special data access stuff goes. It happens to be in code, but it's kind of off and isolated in its own data access layer. This is where the smarts are, and then our higher level controllers can ask interesting questions or ask it to do things like create a user, and they don't have to worry about the details, right? So that's good, right? Pretty simple. Create it, save it. This will update that ID. And here we're going to create an empty survey. So that is like survey. And then we'll just set its properties. We want to set the name to the name. And the survey.createdDate equals, careful, date time.utc now. Survey dot, what is it? Description is the desk. That's almost what I wanted. And then, of course, we have to save it. And this is a generic method, so it'll just save anything we give it. And we'll just say return survey. Right? Pretty straightforward, pretty easy. You guys stop me if you have questions. But it is kind of LINQ to SQL-ish, but you don't say insert on submit and then submit changes. You just do it all at once. There is a way to insert an array of these guys and do kind of a batch insert, but we're not doing it. Now, we can do some query-oriented things. Like if I want all the surveys, and I've made a little note to myself, and I want these ordered by date descending so the newest ones show up on top, I would just say this. Return from S in context, which I didn't point this out, but there's one of these data contexts as a member variable of my repository, so it's always just there. And these are always scoped one-to-one to the controller classes, which is basically one-to-one to the web requests. Okay. So from surveys, order by S dot created date descending, select S. How about that? And we're going to see that this turns out to be really helpful. If we return this iQueryable, this is kind of a pattern that I borrowed from Rob Connery that lets you do most of the work here, but then still layer on logic on top of it at higher levels, and then all at once send that down as a query to the underlying database, so you don't have to do more effort in memory. So all users, same thing, return from view in context.users, order by view.name, select view. Now if we want to update a survey, someone comes in and sends us a survey, right? They got it back, they added some questions or something, they want to save it back. We just say context.save survey. Super easy, okay? Similarly down here, somebody gives us a response and they want us to update the changes, so we'll just say context.save response. And then here, we want to create a new response that somebody's going to answer a survey, so we'll say survey response SR equals new one of those. We want to set, we're getting a survey and a user to associate it with. This is kind of like what you asked about, Brock, with the foreign key stuff. So we're going to say survey ID is survey._ID. User ID is user.ID. Context.save, that response, and then return it for more work. And then later, the update method will be called. All right, last one is give me a particular survey. So that's super easy to do. I can say return from S in context.surveys where S.ID equals this ID somebody gave us. Now, that's probably going to return just one because that's a primary key, of course, but I need a way to tell LINQ to say, don't treat this as a collection, give me just the first one, and if there's no match, give me null, so I'm going to do it like this. Not first or default. Okay, and then that's it. That's our whole data access layer. When we run this, the first time it's going to create the actual database, and we'll go create a survey real quick here. Firing up ASP.NET. It's asking for all the surveys. Oh, hold on, let me do one more thing real quick. In the controller, I believe, in the home controller here, yeah, I guess it's already there, but I can ask questions like, go to the repository and give me all the surveys, and actually just give me the first 5 as an array, and that's what that way of passing back iQueryable, that's what it gives us. Okay, so here, let me do it again. All right, no surveys created. Well, let's go create one. Okay, the survey is going to be sample survey. This will be description. This will be, is this fun? Oops. And then the way the app works, you just put the answers like that. Is this still fun? Is this more fun? Yes. No. Okay. So when I hit create survey, it's going to post this back to the web app. It's going to do all those data access things we just did. And hey, creates a new survey. Now it's listed here. I can go take it. My name is Michael. Is this fun? You bet it's fun. No, it's not more fun. Yes. Hit submit. It'll go pull it back, create one of those responses. And if we go look at the home page now, we can see the results. How cool is that? We basically did the whole data access layer without taking the step of actually creating the data objects, the entities. But, you know, it didn't really take that long to write this demo. So I'll give this to you guys. You can play with it. Go back down here. Let's see. Make this a little smaller so it fits on the screen. Show DBs. Now we have a survey. I could say use survey. Show collections. We got survey, survey response user. I can do things like this, db.survey.find. I can even just ask it like this, db.survey.find.count. There's one. I want to see them all. Here you can see this nested survey with questions, with answers, with choices really. Okay. Questions, comments? I know I'm pushing up on the edge of an hour. I don't want to take much more time than that. So do ask me questions there before we leave this. Otherwise, we'll go kind of quickly through the remaining items and do some more Q&A. Anyone who still has questions? All right, excellent. Well, stick them in that Q&A section if you do have questions. All right, back to this. So there's a more realistic looking application. All right, so I told you one of its features was that it's fast. And maybe you've read a blog post I wrote a couple weeks ago comparing the performance of SQL Server to MongoDB that I kind of went through the ringer for. On one hand, I think there's a lot of interesting, powerful, convincing stuff. And the other, if I sort of tune the SQL side quite a bit, I can get it to look a lot better. It's still, you'll find that MongoDB is faster than SQL Server, and it's free. So, you know, it's pretty compelling in addition to all these neat features of it just sort of shapes itself to your classes. But let me tell you a story real quick that'll sort of reinforce this with some real world examples, right? So this lady here giving this talk called Dropping Acid with MongoDB. She gave this talk, her name is Christina, and there's links to this video at the end. She gave this talk to the MySQL user group in San Francisco, and in there she talks about how SourceForge was bumping up against the limits of their performance with MySQL, and they decided to move over to MongoDB to see if they could get it to go any faster. So they rewrote it in MongoDB, and they tried it with as many users as they normally have, and they were really happy to find out that it worked. And then they said, well, let's do some more testing. Let's see how much it can take. So they gave it more users, 10 times the number of users SourceForge currently has, and it took it just fine. They found that it can handle, now that they switched to MongoDB, up to 100 times as many users as they could before. That's pretty compelling, right? So all the performance comparisons you guys want to run, that's a good real-world example that's super powerful, I think. So anyway, you can watch that video if you like. Question? What about versioning the shapes? Yes. So I would definitely, good question, Jim, I would definitely make my new items or properties nullable, so like nullable date times and stuff. That's really a good point. An alternative would be to run like a data transformation script or application against it, just kind of like you would with SQL Server. You could run some JavaScript stuff in the console. You could write an app that queries it in one shape and puts it back in the other, things like that. But yeah, that's certainly a consideration to think about. It's a little difficult, but yeah, you can do it. Nullable values are a good start. Okay, what next? So looking forward, what things might I be working on? One of the areas where I thought it might be neat to take MongoDB and make some more extensions around it is around the ASP.NET session state provider. Right now you can store it in that state server thing, or you can store it in a SQL Server database. But I thought a really nice middle ground might be to put it into MongoDB and have that as a session and cache provider. Another really nice use of MongoDB would be to use it as an embedded database. So you can ship that mongo.exe file with your application, or mongodb.exe, and then just start it and stop it with your app without a window. And you've got a zero install, high performance, local database you can use. So that's really neat. And then one of my colleagues at Developmentor, Christian Beyer, has got MongoDB running inside of Windows Azure. So Windows Azure, if you're going to run an app in the Microsoft Cloud and you want to have a database, you may well choose to put it into the SQL Azure stuff, but you have to pay for that. Here you get a really nice free database running inside of your system up there. So that's pretty cool, and he's going to blog that later. All right, so when you get started with this, your first steps can be a little bit frightening, right? This is a brave new world, and I recommend that you start small, right? You know, find somewhere where you can use it, see what makes sense, and if that works for you, do more of it. If it doesn't work, well, then, you know, not a big deal. So it is very different, but I've been playing with it for a while now, and it's working great. I just completely love it. So I encourage you guys to give it a shot. All right, now here are a bunch of links, you know, probably too many for you all to take with you, right, just by writing them down, but just give you a quick rundown, and then I'll put this on my blog. I'll also put it on Twitter. Okay, so mongodb.org, without the dot, I guess I forgot the dot, but you can imagine that it's there. Probably the best, there's a bunch of forks and branches on GitHub for the NoRM provider. The best one is this guy named Adam Schroeder. He does a bunch of awesome work on that, and I think his is probably the most up-to-date. Also, Andrew Thicken is really good, and his is on the MongoDB site. Really interesting conversation with James Avery and Rob Connery, the Hurting Code guys, about MongoDB and NoSQL and the pluses and minuses. Michael Deerdorf is on the MongoDB team and was on .NET Rocks, and that was really interesting because, of course, Richard Campbell is on there, who is a super database guy, you know, really into SQL and so on. So they kind of grilled Michael Deerdorf really well, and you know, gave him the skeptic's view, or skeptic's set of questions. So that was good, and it came out well. There's also a DNR TV from the same guy. Michael Deerdorf also wrote a book called MongoDB, The Definitive Guide, which you can get at Amazon or Safari Books Online. Here's the link to that video, Dropping Acid with MongoDB, on my site. You can go visit my website, michaelckennedy.net. I've got links to this webcast. I'll update that with these slides and samples and stuff right afterwards, so check back like an hour later for that. And then I wrote these two articles. This talk is sort of modeled loosely after the NoSQL LINQ article I wrote. I saw there was a question, but it went away. So if you have it, feel free to put it back. Right, so of course I work at Developmentor, and if you guys have any training needs in the .NET space, LINQ, Unity Framework, we're going to probably be running one of our big events called Gorilla.net, where we have kind of like a giant geek party, and I'm going to be doing some MongoDB NoSQL stuff there. That'll be in the fall, so even some of the stuff will be covered. So otherwise, thanks. Appreciate you guys coming. So let me have the questions. Let's see what you guys got. Are there any shared .NET hosts offering MongoDB as a service? Yes, sort of. Now, there may be people like ASP.NET or Discount ASP or something that do it. think it's called MongoHQ. Is that right? Yeah. But at least one possibility is you can host your app somewhere and then get an account with MongoHQ, which hosts the database, and of course you can connect to the database across the internet. All right, so that's one of the options. They're not terribly expensive. Let me look at the pricing. All right, you get a free one up to 16 megs, and the data size is quite small. I mean, this is like compressed binary serialization, so not a lot of size, but even up to 256 megs, you get this. But that's, going across the wire to another machine. Who has a shared host? I'd like to find out. I'm not entirely sure. Okay, Brock, let's see what your question is. So basic trade-offs are pros, performance, data modeling, cons are durability and transaction and reporting. Yeah, those are all significant concerns. Certainly data modeling and perf is a plus. You only model it in one place, right? You don't model it in the database and in code and then try to keep those things in sync. It's just in one place. Durability is a problem, but what you can do is you can say things like, when you do your insert, like that save function I'm calling, you can say, do not return from this save function. Don't tell me it was inserted until it's written to disk. Okay, so that's one of the things you can do. That gives you better durability. You can, in the next version, 1.5, they're talking about giving you the ability to say, don't return from this function when I say save until it's written to this machine and also replicated off onto a separate system that's running as the slave, right? Completely separate machine. So durability, you can kind of make up for it there. Transactions, every individual row or collection, object operation is transactional, but beyond that, there's not like multi-line transactions. So absolutely, yes. Reporting, that's a good question. I'll come back to that. Basically, you can go and imitate the Microsoft guys of years of old, where you just do drag and drop data grid stuff for getting at your data. But reporting, yeah. Rob Connery talks a lot about, saying, like creating a reporting server that you can push the data into, like kind of a data warehouse relational database that you can move it over to for reporting. Okay, it works great for programmers, but what about end users who want to get data out of the system without writing code? Reporting tools. Yeah, there's two basic things. Like I said, I kind of touched on them both a little bit there. One is you can create a separate server, database server, that is simply not there for performance, but it's just completely tuned for reporting, and you just have some system that just moves the data over there. So that's one concern, one thing you can do. The other is if you want something kind of like a SQL Management Studio where you get a grid of data you can look at, then I'll show you just real quick how to do that. How does it compare to Redis or CouchDB? Great question. So I believe Redis has a little bit less durability. It's a little more memory focused, and Redis a little bit faster, but I think MongoDB has better querying capabilities. I'm not 100% sure. CouchDB, I think also you get more queryability with MongoDB than Couch, but I'm not an expert on those other two. I really have only looked at them a little, so take that for what it is. It's kind of my best guess. All right. Perhaps some applications are a good fit for NoSQL and some are more appropriate for relational. Perhaps many applications need a mix of both depending on the data. Yeah, that's a great question, Dave. And it's not inconceivable that you have both working in your system. Like imagine you have an application, let's just pick on Twitter, right? So we could have Twitter where all the user account management stuff happens on a relational database, but then all the tweet data and that sort of thing, like the URL shortening and the image, they're going to get into all those things like the TwitPic, those types of things could happen in MongoDB, or they're using Cassandra, but also a NoSQL database. So you can definitely do mix and match for several reasons. Yeah. Is there a size limit where MongoDB is not usable? I suspect at some point there is a size limit, but it's quite large. It's meant for holding huge amounts of data with its scale out options. So there probably is, but it's definitely lower than what the traditional relational databases would do, what they could take. So take that for what it is. However, here's an important point. If you run this on 32-bit windows, MongoDB will only take up to 2 gigs. The database size is limited to 2 gigabytes because they're kind of limited by the pointers, and they don't want to try to maintain both systems. They say, you know, the future is 64-bit, so just run it on 64-bit if you want to do real big sets of data. How does it compare to Cassandra? Oh, that is a great question, which I don't have an answer to. I'm sorry. I know Cassandra is one of the more deployed ones out there, you know, invented by Facebook. Facebook and Twitter are both using it, but I'm not entirely sure about how it compares. Sorry. Good question, though. What about security? There's pretty much binary security. Yes, no. Security is basically I want to use a username and password or I don't, and it's just server-wide. It's not even database-wide, so you don't get real granular access. Like this collection can be accessed by admins, but this one can be accessed by all users. If you talk to the guys on how that should all work, they're largely like that should just probably be done in the app, and just don't expose this thing to the internet if you have that kind of data. Okay. Yeah. All right. Since you guys are all out here, I got a couple of questions on the reporting stuff. You know, let's go and just do one more real quick thing here. Let's go and add a Windows Forms app. Oh, lovely. Call this reporter. So imagine I want to be able to interact with that data. I could do something like this, right? Find a tab container. There you are, down here somewhere. Tab control. All right, just real quick. I guess I got to do it over here. So we'll go over here, and we could go into this section and add just a data grid view and dock it like that. Okay. So let's go and add a reference to our data access layer. And when this thing loads up, we could just do something like this. I could say, let's say this bar surveys. Dot. Survey repository. All surveys. We'll just say data grid view1 dot data source. All surveys. Like that. And I forgot to set that as a startup, so I'm not going to do much. But let me make one more survey while we're at it. Test. Okay, so there's our two surveys. Oh, yeah, it's enforcing that I set the name, which is a good idea. And what did I call it? It's got to be the same as what I called it before, so let me be careful here. I think I did that in the global ASAX. I set it to survey. Perfect. That wasn't great. Say data bind, maybe. Oh. Here we go. Alright, so I know that it's not super great as compared to like a real management studio or something, but you can see with a little bit of just flipping together some of the poor architectural choices that Microsoft used to suggest we use to write our apps, we can pull together a pretty decent show me my items. If we do things like this, let me do this here. Actually, that's not what I want. I want let's do this. Let's really quickly here rework this so that I can hold on to these across the lifetime of the app. I guess it hardly even matters. And if I go to the form close, go to the events in this thing, I can even make this editable. Just say this for each thing in surveys. Repository update survey. You probably want to put like a dirty flag in there or something so you check, but watch this. I see there's a question. I'll answer it in just a second. So I can go over here, run this app, which seems like it's not starting. Is there an error with it? Maybe. Let's see. Oh yeah, there's definitely going to be an error here. Hold on. Because I have to set the repository name before I call new. So let me just do it like that. Okay, so they're over here. And what if I want to rename this second survey to be the best survey ever? If I close this, if I tab away from it and close it, it'll go and realize that's changed, and it should come back. It should be live, the best survey ever. Okay, so you can kind of make it a pretty decent little editor grid. Great question. Yeah, so have I tried LINQ pad with no RM? No, but a guy did ask me about that today on Twitter. Let me see if I can find it. If I put the links in there, I think. A little bit down, let's see. Now, you can implement your own custom LINQ pad data context integration piece, and you could use the stuff that we did now to get to, you use NoRM to get on there. Yeah, you think so? Okay, well, that sounds pretty cool. Let's see. While you guys are out there, if you have any other questions or anything, feel free to ask them. So you say F4, huh? Add. Browse to my desktop. There it is. All right, Jim, you have to help me. And what do I do after I have that in there? Do I just say like DAL, like capital D-A-L? DAL. Maybe this. Yeah, I'm not sure. All right, I'll play around with it though. That's good advice. Anyone else got any other questions? Yeah, it looks like one in there. Can you use the norm driver and get these strong object types like customer orders while still getting dictionary-like access to additional data properties? Super good question. You definitely can with MongoDB. I don't know about norm. They're really embracing the LINQ style of doing things, so they're very focused on that. My first guess is kind of no. But if you look, I showed you the 3 choices. If you look at the simple MongoDB, yeah, thanks, Jim. And if you look at the simple MongoDB, you basically program it like a dictionary. You say, okay, give me this thing. Does it have this property? Okay, give me its value as a string, and I'll convert it, and so on. If you use that driver, you could get that. I'm not sure about how well you mix and match those, though. Yeah, thanks. Sounds good. And I'm, of course, if you want. All right, anything else? I will put these demos up for you to download. Another question, all right? Probably fetch the JSON, run it through JSON.NET, and then use the JSON deserializer to populate your objects. Yeah, I bet you could. That's a good advice, Rick. Now, with the NoRM provider, I don't believe you can ever get access to it, but it's open source, so you could go down to the level where it is and then go from there. I think they don't ever actually turn it to JSON. It comes across the wire in BSON, and then but they have a BSON deserializer you could mess with if you wanted that. Yeah. More questions? I'll stay and talk with you guys, but I don't want to keep you longer than you want to stay. All right, well, I think that's it for the questions. So I want to thank you all for coming and hanging out with me and all the questions and interactions. It was great. I'll put this stuff up on the website, and of course this has been recorded in audio and video or screen sharing formats, so you can download it and take it with you and play with it and so on. So once again, thank you, everyone. Have a great day.